If you look at the duration of Hadean Eon and find out how many million years, and then you find out for Archean it is how many million years, you will find that they do not match. Similarly, the duration of the Archean Eon and the Proterozoic Eon will not match, that between Proterozoic and Phanerozoic Eon will also not match. The question comes, what is the basis of this classification? That also we will see progressively. Now, we see that the International Chronostratigraphic Chart published in 2024 and in the month of December, as per this code, is discouraging the use of the term early and late in dividing the different periods. For example, earlier we could have called this as the early Cretaceous and then this one as the late Cretaceous, but as you see, early and late, these words have been abolished from the names of epochs. Here if I keep on checking, there is no such terms as early or late. Also have a look over here, we do not see early and late terms over there. Now, we are going to divide epochs into several ages, which is the smallest geological time unit, and the equivalent chronostratigraphic term is stage, and which was stated over here. Ages are equivalent to stages. Students have to remember Eon, era, period, epoch, age, system, series, stage. System is equivalent to period, series is equivalent to epochs, and stages is equivalent to ages. Let us look at these ages within the International Chronostratigraphic Chart. We do not see any ages within the Hadean, not in Archean, not in Proterozoic. However, we start getting the ages or stages in the Cambrian onward over here and also over there. So, what it means that the geological time scale is crudely divided for the first few billion years in the earth history, including Hadean and Archean and Proterozoic, and as time progressed and life flourished and kept on evolving on the earth through the biostratigraphic means, by studying fossils, we were able to divide the series or epoch into stages or ages. You see here the names. For example, in Cambrian there are age or stage such as stage 2, stage 3 and stage 4. Note that stage 2 is not part of series 2. Series 2 consists of only stage 3 and stage 4. So, again there is non-uniformity of classification, and then there is a stage 10 coming over here. And if we keep on looking the other names of the ages or stages, we do not see stage 2, stage 3 or stage XYZ anywhere in the column, such as over here and over there. I repeat that whenever we say present, this word in stratigraphy, we mean precisely the year 1950, which is the beginning of modern isotopic research. And from today till 1950, that means the day on which you are watching this video till 1950, that time can be called as an offset. Note that this term BP 2000, what it means? Before present, when the present means the year is 2000. So, if we want to change the meaning of the word present, we may use BP 2000 in this way, where this indicates year and this is the present. Note that the time unit second can be defined in two ways. One is the solar second. What is that? It is deduced from Earth's rotation. It is 1 divided by 86,400 of a solar day. Now, we know that since the Earth's rotation is non-uniform, the definition is inaccurate. Whereas, there is another unit known as atomic second, and it is deduced from the atomic clock and it is accurate. It is deduced from the radioactive elements. Radioactive elements decay. There are other units such as the ephemeris unit and mean solar second also. What matters to the stratigraphers chiefly, at least in this NPTEL video, will be solar second and the atomic second. Now, here is the geological time scale, but it is a bit older version. With time, actually these ages kept on modifying, and this is a global collaboration which is done under the umbrella of International Commission of Stratigraphy, which is a part of or a subgroup of the International Union of Geological Sciences. So, if I move from version 2024 into an old one, which is 2004, some of these ages given here will not accurately match. Students need to follow the 2024 version, and if any new international chronostratigraphic chart comes, then we have to modify those ages. But we will note that the age does not significantly vary. We can take one example and compare between a 2024 version of the chart and a 2004 version. For example, let us take the timing of the end Cretaceous, which is here 65.5 million year, and if we go by the latest one, it is 66 million year. With time, with subsequent time, we may find further revision, but you will also observe that this 65.5, 66 million year, it will be remaining within this range. Fine tuning happens. Now, we have to focus on the term global standard section and point, GSSP, also known as the golden spikes. GSSP is an internationally accepted reference point within a specific rock section. That means an exposed rock section is there and a specific reference point is understood, which defines the lower boundary. For example, if I want to fix this particular time, there must be an analog from where it has been found. That rock section can be called as the global standard section and point, also can be called as the golden spike. And the GSSP approach is biostratigraphic based on fossils, but for older rocks, let us say Archean rock, then geochronology will be more useful, and then we do not call GSSP, then we call it GSSA, which is global standard stratigraphic age. Now, how the different names in the geological time scale came? For example, Cambrian name came from Cambria, Ordovician and Silurian comes from some tribal names, Devonian comes from the location Devon, Jurassic comes from the Jura mountain in France, Carboniferous from the coal bearing rock character, and Cretaceous is a Latin for the word chalk. So, we see that the different names that are there in the geological time scale, their origin of these words are non-uniform. For example, there can be names of tribes involved, there can be some locality or the nature of the rock, such as is it chalk or is it coal bearing. Carboniferous, that means in this geological time span, from this time span to that time span, coal formed significantly on the earth, but this is not the only time when coal formed, but this is a significant duration when marshy environment were there in several places and coal developed. When we say Cretaceous, this is the time where we have good chalk deposits on the earth surface. The GSSP points have been presented in this world map, and we see that there is one location coming from India, and we will see subsequently this is from Meghalaya. We will see the detail in due course. Now, interesting to note that we do not see anywhere on the earth a rock section starting from Archean till the end of Holocene. It does not exist. Things have been established in bits and pieces in different sections of the earth, and then this table has been created. So, it is essentially a compiled table. The information has been gathered from different parts of the world which can be widely separated, and then that has been compiled. So, remember, it is a compiled table. You may find Archean Proterozoic contact and these rocks exposed in some part of the earth. You can find out the Cretaceous Tertiary contact. You may find some Silurian rock exposure at some place in the world. You may find Cambrian Ordovician boundary. So, what are the words that a geologist has to remember? Archean and Proterozoic, and call it together as the Precambrian. Note that below Archean is Hadean, which is over here. It is not written here. Then Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous, Paleocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene and Holocene, and also to remember Paleogene and Neogene. One has also to remember Paleozoic, Mesozoic and Cenozoic. One has also to remember the word Archean Proterozoic and the word Phanerozoic. So, these are the things to remember. In my course, students need not remember each and every term. For example, now what I am covering through an ellipse, these terms are not required for you to remember. Then what are the edges we have to remember? The Hadean Archean boundary, this edge which I have already mentioned. Then the Archean Proterozoic boundary, which is 2500 million year, you have to remember. The Precambrian, that means Archean Proterozoic taken together, and Cambrian, this boundary 542 million year. Then the Cretaceous Tertiary boundary. Cretaceous means the topmost part of the Mesozoic, and Tertiary is above portion is Tertiary, a word which is not in the geological time scale, but frequently it is used. That is 66 million year. As per the latest one, here it is 65.5. You have to remember as 66 million year as the KT boundary. Then Holocene started 10,000 years back. Is last 10,000 years. The geologists celebrate GSSP. They keep meeting, they visit the field and mark out the importance of the rock, and it is an international collaboration. Now, the question comes, on what basis this non-uniformly the time has been divided in the geological time scale? The answer is, major events on the earth led to classify time into non-uniform sectors. I can write here major events. Some of them we are going to see right now. Mass extinction events, where organisms die and maybe new organisms come into the picture. The end Cretaceous, note it is 66 million year, which I said as KT boundary. What happened? Many species disappeared. Volcanism was widespread. For example, the Deccan Trap, large igneous province in India covering Maharashtra, southern part of Gujarat, the Kathiawar area or the Saurashtra area, part of central India, that eruption happened at the KT boundary, impact of asteroids on the earth's surface. In end Cretaceous case, birds, mammals and spiny red fishes evolved, whereas most interestingly the ammonites and the dinosaurs, do not forget these two names, got extinct. The end Triassic, how we define the end of Triassic 201 million year back? It was again based on some extinction, and note that whenever there are some losers, that means extinction happens, there are also some winners, some organisms start evolving. Calcareous sponges got extinct, and note if any organism got extinct, that one in exactly that form never comes back, dinosaur never came back. 201 million year back, the siliceous sponges started evolving. Going further in older rocks, end Permian 252 million year back, certain brachiopods got extinct, carbon cycle got disrupted. As ocean acidification happened, global warming took place. These days we have been talking about global warming, but global warming has been a common incident on the earth as per the geological record. For example, in late Devonian also we find global warming. Whatever I am underlining becomes important in your NPTEL exam. Not each and everything you need to remember from here. Late Devonian around 372 million year back, what happened? Certain species got extinct. For example, certain corals got extinct, but note that not all corals got extinct, and there are still some coral reefs on the earth, but those are under environmental pressure. Very old rock around 443 million year back, late Ordovician, then siliceous sponges were the winners, corals were the winners. Do you note that the siliceous sponges were winners 2 times in the geological past? We may note these timings over here, and these are known as the big 5 mass extinction event, end Cretaceous, which is over here, end Triassic, which is there, end Permian, which is over here. This is from the old geological time scale, where the time is 251 million year, whereas the latest one is 252 million year back timing. Late Devonian, so here it would be this one, upper Devonian, and that is the time span which we are talking. Late Ordovician, which is basically as per the old term upper Ordovician, this is the time. So, this is the time where important mass extinction happened, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Again, coming back to the big 5 mass extinction events, volcanism has been a cause of mass extinction not just once, but twice, thrice. How many times glaciation has become very important in the past? Glaciation 2 times clearly visible within the big 5, once in late Ordovician, another in the late Devonian. So, as I said, the things that I have marked by arrows or underlines, it becomes important for the students to remember. They are not each and everything I am asking you to remember. So, other than these 5 mass extinction, there are reasons of dividing the geological time in this way, and we will see those details, the geological time scale in detail, what kind of changes took place, the different events. We are going to see the oldest eon, the Hadean Eon, in some detail. This term Hadean was first proposed by Cloud in 1972, which means in Greek the god of underworld. Almost half of the lunar rocks in the moon are very old, 3.9 to 4.4 billion year. The lower bound of the Hadean is defined by the termination of the late heavy bombardment of the meteorites. However, the very existence of the LHB has also been debated. What is the oldest record of mineral or rock? It is the Acasta gneiss, which is 4.02 billion year old, which is found from the Slave Craton in northwest Canada. From this time up to the subsequent gross differentiation of the earth into metal and silicate layers can be taken as an elastic definition of Hadean Eon. Now, if this timing gets modified by subsequent geochronological understanding, and if this timing also gets modified, we will also keep on changing the duration of the Hadean Eon. In this connection, note that earth had accreted most of its present mass by 4.55 billion years. What do we mean by accretion here? Planetesimals were moving in the then solar system and they were haphazardly colliding. They got accreted and different planets got formed. Earth is one of them, and this kind of accretion, this view says that around 4.55 billion years back accretion was almost done. Now, how do we know the age of such old rocks? Are we getting rocks? The answer is no, we do not get rocks as such for dating, we get zircons. The formula is ZrSiO4. Now, this very the Hadean zircon has been documented from as many as 15 terrestrial localities in Australia, Asia, Africa, North and South America. Hadean zircon has also been found from the stony and Martian meteorites and in the lunar rocks, the rocks from moon. Interestingly, when we say Asia, we have from the Singhbum Craton in India, in the eastern part of India, such very old Hadean zircons. We have so far not reported Hadean rock. Hadean mineral has been reported. This is important. The Hadean earth had less than 10% of the 4,800 mineral species. Just to remember that when the earth formed for first few millions years or so, we did not have the complete variety of around 4,800 minerals that we have got on the earth right now. The earth's upper mantle appears to have remained relatively oxidized since the Hadean times. This is also an important piece of information. And with the finding of the Hadean zircon, the previously held view that no continental crust formed during the first billion year of the earth is now refuted. Interestingly, primary graphite has been reported from the igneous zircon, and this graphite inclusion has found to be around 4.1 billion year old, and this possibly indicates the origin of the life in the Hadean Eon itself. But note that this is debated. We are not getting into the detail of each of these statements. Have a look at the Archean cratons shown by this color in the world map, and also look at the different spots. And as I said, from Singhbum we have got very old rocks. These are the sites of 3.3 to 4 billion year old rocks. It is not about 4.02 sites of 3.3 to 4 billion year old rocks. So, in India we have in Dharawar Craton, in the Bastar Craton, in Singhbum Craton, and in the Aravalli and in the Bundelkhand Craton very old rocks